Now over to angular acceleration. Now, angular acceleration is the rate of change of angular velocity. That is what angular acceleration is. The rate of change of what? Angular velocity. So now, angular acceleration alpha. Okay, let's get a formula for that. Now, from v equals to radius times what? Omega. So when you divide by t again, we have v over t is equals to radius times omega over t. So this v over t is what? Linear acceleration. That is a is equals to v over t. You know the formula of acceleration, which is velocity over what? Time. So this one is equals to, r times omega over t. Now, omega over t is what? Angular acceleration, which is alpha, equals to omega over what? T. That is the rate of change of what? Angular velocity. Okay? So now, when you substitute everything here, we now have that A is equals to, that is r times omega over t. So r times omega over t, that is r times what? Alpha. So A is equals to r alpha. This is the formula that relates linear acceleration to what? Angular acceleration, in case you are asked the question. So linear acceleration, you know what linear acceleration is. Linear acceleration is the rate of change of what? Of linear velocity, okay, with time. That v, you see this v, v is the linear velocity. V is equals to radius times omega. This is the angular velocity. Linear velocity, angular velocity. Okay. So you know how to differentiate them. So it is important you know the definitions and the formulas of these concepts. It's very, very important. So that's it. Now, I've defined everything that you need. Okay. What remains now is question, and there is one again that I need to talk about, and that one is banked angle. Like, see what I mean? A car moving along a banked angle. Okay, that is an angle. That is an elevated what? An elevated ground. Okay, a car moving round this elevated ground, like the ground is inclined at an angle theta to the horizontal. So that is the one I will consider later. Okay, but before that, I will give you some questions to solve on this. Now, you see, this circular motion is a very important topic, honestly. Like, just imagine, in fact, every planet you are working on, you are describing a linear distance, and also with respect to the center of that planet, you are also describing what? An angular distance, which is theta. Do you understand? So just think about it for a moment. You see, so this is like a relationship between linear and what? Angular distance. You see why this thing is very, very important. Someone says that straight lines do not actually exist. I thought it is in a geometry, a branch of geometry called Riemannian geometry. That is, non-Euclidean geometry. Non-Euclidean geometry. Yes, that is the geometry of Riemann. Yes, the geometry of Riemann, one great German mathematician. He says straight lines don't actually exist. What we have everywhere is what? Curves. You understand? Curves, like, curvature. So everywhere. So that is it. So this thing is really, really interesting. This circular motion is really, really interesting. It's far deeper than linear motion. Okay, I will come back for questions.